All right, welcome back, you guys. We're going to finish out talking about angular and linear speed. So, angular speed is the angle theta that can be swept out in time t. So, here's our formula for that. We got the omega equals theta over t. For example, like the turning rate of an engine is an example. So say an engine is idling at 900 revolutions per minute. That would be your angular speed, 900 times around for every 1 minute, right? So it's being swept out, right? It's going around 900 times per minute. Well, if we were to put that in terms of radians per minute, you know that there are 2 pi revolution, 2 pi radians per each revolution, right? So you see how your revolutions cancel. And so your angular speed, 900 times 2 pi would be 1800 pi radians per minute. That would be our angular speed for this engine that's idling at 900 revolutions per minute. Okay. Now, linear speed, on the other hand, is the speed at which a point on the circle is moving. Okay, so I like to think about you've got a child spinning the rock on the end of a rope. So like here's this rope, it's got the rock, right, and it's spinning around. They're spinning it around, right? It's how much is swept out over time t. So it's like your arc length, right? This is your arc length over time t. So linear speed is the arc length over time t. Arc length. How much is swept out? Distance swept out over time t. Well, if you remember from our discussion before, our arc length on a circle is the radius times the central angle. So I'm replacing s with r times theta. And let me rewrite that as r times theta over t. And I say that because theta over t, that's our omega. So our linear speed is actually r times our angular speed. That's the relationship, right? So it's how much distance is swept out over time t. So, but that's the relationship between the two. So let's do an example here. We got a circular gear rotates at a rate of 75 revolutions per minute. What's the angular speed in radians per minute? So number one, we're given, in order to find the angular speed, we need to find the angle in radians, right? So we've got angular speed is theta over t. And this is 75 revolutions per minute. And so we've got 75 revolutions per minute, right? It's going around 75 times per minute. And now let's do that in terms of radians. We know that there are 2 pi radians for every 1 revolution. And so we end up with 150 pi radians per minute. And that's our angular speed, right? There's our angular speed, 150 pi radians per minute. So for the linear speed, so now there's our angular speed. Let's do the linear speed now. So we know our linear speed is the radius times our angular speed. And it says, what's the linear speed of a point on a gear that's 3 millimeters from the center, right? So if this radius is 3 millimeters from the center, 3 times our angular speed. So 3 millimeters is our radius. 150 pi per minute. And so our linear speed here is 450 pi millimeters per minute. Okay, let's do another one. We've got a wheel that rotates at a rate of 2160 degrees per second. Now we want this in radians, you guys. So we have 2160 degrees per second. Now we want this in radians. We want this angular speed in radians per minute. Radians per minute, right? So let's first convert this to radians. So I'm going to multiply by pi. There's pi radians for every 180 degrees. Okay. And so we get 2160 divided by 180. Notice that the degrees cancel. And we get 12 pi. Okay, so now I have this as wheel rotating at 12 pi radians per second. Okay, so let's go ahead and find our angular speed first, which is theta, the rotation over time t. Well, what we have is it's 12 pi radians, and right now it's per second, they said, per second. We want it in per minute. They asked us to do it per minute. Well, we know there are 60 seconds for every 1 minute. And so our angular speed ends up being 12 pi times 60, so we get 720 pi radians per minute. Okay, so here's our angular speed. So now let's do our linear speed. The linear speed is radius times the angular speed. And so we've got, they say, what's the linear speed of a point on the wheel that's 30 centimeters from the center, right? So if you're 30 centimeters is our radius, 30 centimeters from the center, times our angular speed, which is 720 pi radians per minute. And it looks like our linear speed ends up being 21,600 pi centimeters per minute. To approximate the speed of the current of a river, a circular paddle wheel with a radius of 4 feet is lowered into the water. If the current causes the wheel to rotate at a speed of 10 revolutions per minute. Okay, so that's key there. They're giving us how much it's being swept out at, revolutions per minute. What's the speed of the current in miles per hour? So water moving, that's a linear speed. So number one, we're going to start with that angular speed information that they give us. Okay, so angular. So remember, angular speed is how much it's swept out over time t, right? The central angle over time t. Well, they're telling us that the angular speed here is 10 revolutions per minute, right? They tell us that. It's rotating, this wheel is rotating 10 revolutions per minute. We want this, though, in terms of radians per minute, right? So remember, each revolution is 2 pi, one time around, 2 pi radians per revolution. And so our angular speed here is 20 pi radians per minute, right? Again, we're wanting this in terms of radians. Radians is actually unitless, but I put the radians on there so you know that real number 20 pi is now in radians, right? So there's no attached unit to it, if you will. Number two, then the water moving, that's our linear speed. Okay, so we've got the linear speed is the radius times our angular speed. And they want to know what's the speed of the current in miles per hour. But we've got this wheel with a radius of 4 feet. So that's what we got to use. So speed of this thing, we've got a 4 foot radius. And then we're going, our angular speed is 20 pi radians per minute. Okay. And so it looks like our linear speed is 80 pi feet per minute. Now notice though, they wanted this in, what's the speed in miles per hour? Miles per hour. Right now we're in feet per minute. Right now we're in feet per minute. So let's go over here. Right now I'm 80 pi feet per minute. I want it in miles per hour. Well, let's get it in hours first. So let's multiply. We know there's 60 minutes for every 1 hour. So now we're in feet per hour, right? Notice we're in feet per hour right now. Again, we want miles per hour, not feet per hour. We want miles per hour. Well, we also know there are 5,280 feet per mile. So 1 mile for every 5,280 feet. Notice my feet cancel. So we're left with miles per hour. Miles per hour. So let's go ahead and multiply this. I got 80 times 60 and divide that by, so 4,800, right? Over 1 times 1 times 5,280 miles per hour. So, and I punch that in. Oops, I forgot my pi. Sorry, 4,800 pi. Don't forget that dang pi right there, over 5,280. And it looks like this will be 2.855993332. So 2.86 miles per hour is the speed of the water. Okay. Thanks so much for watching. See you next time.